So just before we go on, someone wants me to do f here, so let me just do that one. Minus 4x cubed minus 18x squared plus 12x plus 11. Let's just have a look at that.
Should be minus 4 x over 4.
Yeah.
X over x up to 4.
Yeah. Yeah. Correct, yeah?
Over 4, yeah?
Yeah.
Yeah, but the answer here is wrong in the
What's the answer at the back?
minus x over 4.
Yeah.
And
Oh.
minus 6 x over
Scroll down, check your answer.
I know what I'm doing. Minus x4. Yes. You think that's wrong? Because you have a 4 and a 4, they cancel.
Okay, the next one.
Okay, 6x cubed. So that would be minus 18x cubed over 3. 18 over 3.
After we can see simplify.
Yeah. Alright, okay. Let's go to the next topic. So, guys, we'll continue. So, in the previous lesson, we learned how to integrate. And we get some answer plus a c. This is called a indefinite integral. What we're going to look at now is called a definite integral, where we have numbers here. And really this is nearly the same thing. Having the numbers here, it doesn't change too much. For your vocabulary, this one is called an upper limit and this one's called a lower limit. So what is the difference when you have these limits in here? Let's take an example. 0 to 1, 2x. What you do is you integrate like normal. So what's the integration here? X squared plus c. And the difference is now with the limits, you put in the values 1 and 0. So you put in 1, you get 1 plus c. You put in 0 and you get 0 plus c. And then you minus the two answers. And in this case you're left with 1. Now what you notice here is that the c's should always cancel. So you don't even have to bother to write the c in anymore. So here, let's have a look at another example. Let's say 2 to 3 x dx. Integrate, what does x become? X squared over 2. Put in the limits. Let's put in 3 first. We get 9 over 2. Minus, let's put in 2. We get 4 over 2. Right? Yeah? This will equal 5 over 2. They're not much different. I've just added in one extra thing to do. But there are some cases where we have to be careful. So let me just give you one to try and then we'll talk more about special cases. 2 to 4, 1 over x dx. I want you to try this and to simplify your answer fully. It's still integration, but it's called definite integration. Whereas the last one, technically, is indefinite integration. So we have this adjective, definite and indefinite. Not this, I want the exact simplified answer. I want exact and simplified. Got this? Yeah? Okay. So this becomes, what's the integration of 1 over x? Log x. 2 to 4. This is log 4 minus log 2. But I said to simplify using the second rule of logs. This is log 4 over 2, which is log 2. And this is the exact simplified answer here. Log 2 is the answer. No. The word exact means not a decimal. Not simplified. Because 4 over 2 is 2. Yep. Okay. Try this one now. Got an answer? Kind of. Okay. I just want to make a small change just to annoy Yusuf. Can you just change this to 2 now? Yeah.
was nice.
Yeah, it was. Too nice. I didn't like how happy he looked. He's sitting there like, yeah, 0. Take that. Now do you have an answer?
What?
No. Hmm? Which is what? Exactly.
Why did you change it to 2?
Because Yusuf was too happy with 1. True story. Okay, Yusuf, let's do. What? Let's have a look here. So this becomes log x minus 1 to 2, which becomes log 2 minus log minus 1. So this becomes log 2 over minus 1, which becomes log minus 2, which becomes
No answer.
error. So we actually don't have an answer here. We call this situation an improper integration. It was not proper to do it. It was improper. Now, there is a way to tell from the beginning that it was improper. And I wonder if anybody knows how to see from the beginning that it was improper. The minus wasn't a problem here really, because if you had something like this is not a problem, because this becomes x cubed 2 and minus 1, which becomes 8 minus 1, which becomes 9. There's over 3, so I'll just cheat by putting a 3 here. Okay. No, the negative's not a problem. It's not the negative that's making the problem. It's the log, but how can you know from the beginning? Well, let me tell you, yeah?
It has a negative limit and 1 over
negative and a log.
No, because watch this. Can you watch carefully, please? Karen, please watch carefully. This is important. So, a lot of people are thinking the problem is because it's negative, but it's not. Watch this one example. Let's say I have minus 2 to minus 4, 1 over x dx. So,
when 1 is minus and 1 is positive, then it's 1 over x.
no, you see, but you need a simple rule, and you're making it too complicated. This becomes log x minus 2 to minus 4, which is log minus 4 minus log minus 2, which is log minus 4 over minus 2, which is log 2. So, give me a simple rule. When the... No. Now,
Yeah, maybe when it's like this one over x, and there is a minus, one minus.
yeah, but we need a simple rule. That's only for this case.
The upper limit has to be lower than.
That's what he just said. The dude right beside you literally just said that.
We give up, kill us, teach us,
I'll teach you.
enlighten us.
I'll enlighten you. So the problem is, what was the original? Minus 1 to 2, wasn't it? What you do, the way you can tell is, in your mind you picture the line from minus 1 to 2. So here is minus 1, and here is 2. And as you move from minus 1 to 2, you ask yourself, do I hit any values which I cannot use here? Yes. As I move from minus 1 to 2, I pass through 0. And 0 is not allowed here. But if you look at this example, minus 4 and minus 2, as I move from minus 4 to minus 2, do I hit anything I can't use here? No. So I can tell from the beginning that this one is a problem, because as I move from minus 1 to 2, I pass through 0, and 0 is not allowed here. Here's another example. Let's say I go from minus 1 to 2 root x. Proper or improper? Improper, because from the very beginning I'm using a value I'm not allowed to use, minus 1. What about minus 1 to minus 2 root x here? Also improper. As I move from minus 2 and minus 1, everything is forbidden. Very simple. Very simple. I can't use negatives in roots, so everything's forbidden here. What about, let's say, this one here? Let's make it a little bit harder. Minus 2 to 2, 1 over x plus 6. Proper or improper? Proper, because as I move from minus 2 to 2, I don't include any values I shouldn't. What should I not have here for x? Minus 6. Minus 6 is not in this range. So this is how we can know from the beginning if we are allowed or not allowed to integrate. If there's a forbidden value in the range. Okay? So these are only two new things for this lesson. Firstly, when you have limits, we just integrate and put the values in.
So always the bigger minus the smaller.
The top minus the bottom.
So we can have negative.
Yeah, that's fine. It's just top minus bottom. And the second thing for this lesson is if you integrate, this is only valid if x between a and b is valid in fx. So as long as all the numbers from a to b can be put in, then we're good to integrate. So these are the two extra rules for this class. I'll let you try some of these. Homework. Question 1, question 2. Yes? Question here? Oh, you need to write it down? Yeah.
If it's improper, so we just write improper.
Yeah. Yeah.
Without trying to solve.
No, because it's not right to integrate an improper integral.
What if the answer is 0? Does that count as proper or?
What answer? The final answer?
Yeah.
That's fine.
Like if we're integrating a constant.
Well, integrating a constant wouldn't make 0, but I know an integration that would make 0, like minus 1 to 1 of x would make 0.
No, but like integration of 3.
Oh, like integrate 3.
Yeah.
Yeah, from like
0.
to, yeah. So this would be 3, because it would be 3x 0 to 1.
Yeah, so 0 plus 3. Okay.
Okay. Yeah. Oh, I mean to say there are two new things you learned. Proper, improper, and how to deal with limits. Where's my... Right, so let's see. Question 1, you could do a linear f, g, j. Question 2, A, B, C, D. And then question 3. We'll just give you...
4 times 4.
Yes, but I can only do one thing at a time, despite my amazing powers. Question 4. A, B, C, D.
So it's all.
But it looks better this way. Okay. Can you start them now for a few minutes, please?
Can you subtract enough or?
Yes, once you wrote these letters down. Because I'll have to close this, stop the video. Lee! Andrew, are you working on this?
Yeah.
Good. Please work on this. Can I close this? Did you write these down? I can switch back to the questions? Yeah.